Topic: Buffer Overflow Attack 1. Introduction. A buffer overflow attack is one of the most common and dangerous security vulnerabilities in a computer system. It acts as an intermediate storage area between different components such as the processor, memory, and input/output devices. Buffers help in managing data efficiently by holding it until the system is ready to use it. For example, when a user types data using the keyboard, the input is first stored in an input buffer before the program reads it. Similarly, when data is read from a file or received from a network, it is stored in a buffer before processing. In programming languages like C and C++, character arrays are commonly used as buffers. What is buffer overflow? A buffer overflow happens when a program stores more data in a buffer than its allocated size. Since every buffer has a fixed amount of memory, it can hold only a limited quantity of data. When this limit is exceeded, the extra data flows into nearby memory locations that are not meant to store it. As a result, important memory areas such as variables, function pointers, and return addresses may get overwritten. This can change the normal behavior of the program and may cause errors, unexpected results, or system crashes. In serious cases, attackers can intentionally use buffer overflow to insert malicious code and take control of the system. Types of buffer overflow attacks are stack-based attacks. A stack-based buffer overflow occurs in the stack memory, which is used to store function calls, local variables, parameters, and return addresses. When a program writes more data into a stack buffer than it can hold, the extra data overwrites nearby memory locations on the stack. In this type of attack, attackers mainly target the return address of a function. By overwriting this return address with a malicious address, they can control the flow of program execution. When the function finishes, instead of returning to the original location, the program jumps to the attacker's code. This allows attackers to run unauthorized programs and gain control over the system. Example of buffer overflow: C program. Hashtag include less than stdio. H greater than hash include less than string. H greater than int main. Char buffer 10 gets buffer. Printf %s buffer return 0. How attackers exploit buffer overflow. Attackers exploit buffer overflow vulnerabilities by deliberately providing very large or specially crafted input data to a program. This excess input exceeds the buffer's storage capacity and overflows into nearby memory locations. As a result, important memory areas such as variables, function pointers, and return addresses may be overwritten. By modifying these memory locations, attackers can change the normal flow of program execution. They may insert malicious code, redirect the program to execute harmful instructions, or gain unauthorized access to system resources. In many cases, attackers use this technique to steal sensitive information, install malware, or take full control of the affected system. Prevent buffer overflow attacks. Programmers should use safe input functions that limit the amount of data entered into a buffer. For example, functions like fgets and scanf with proper format specifiers should be used instead of unsafe functions like gets. These safe functions help ensure that input does not exceed the buffer size. Programmers must also perform proper bounds checking before storing data in memory. This means verifying the length of input and making sure it fits within the allocated buffer. By checking limits, programs can avoid writing extra data into unauthorized memory areas. In addition, modern security mechanisms such as address space layout randomization (ASLR) and stack canaries should be enabled. ASLR randomly arranges memory locations. Conclusion: buffer overflow attacks are serious threats caused by improper memory handling. Secure coding practices can significantly reduce these risks. 9. References 1. Operating System Textbook 2. OWASP Security Guide 3. C Programming Documentation.